In this video lecture, we will go through a third type of bond, which we call as a coordinate bond, right? Coordinate bond or a dative bond. Right? It's a coordinate bond, right? Or we also call it as a dative bond, right? And before this lecture, we have gone through two types of bond, right? The first was electrovalent bond, right, and the other was covalent bond, right? In electrovalent bond there was transfer of electrons, right, and in covalent bond there was sharing of electrons, right? Now this coordinate bond, if in short, if I say, it's a combination of an electrovalent bond, right, and a covalent bond, right, and a covalent bond. So what happens is, in coordinate bond, this bond first of all is formed between two dissimilar atoms, right, say between A and B, right, and one of the dissimilar atom, right, one of the atoms will possess a a lone pair of electrons, right? This bond is formed between two dissimilar atoms A and B, and one of the atoms will possess a lone pair of electron, right? A lone pair of electron, we know, is a pair of electron that is not involved in bonding, right? So what happens is, the atom that possesses the lone pair of electron, right, that is in this case atom A, right, that has this lone pair of electron, right, will transfer its lone pair of electron to the other atom, right, to the other atom B, right, which is short of electrons, right, to complete its octet, right, or doublet, right? So the atom, right, the atom that transfer its lone pair of electron to the other atom, right, which is short of electrons, we call it as a donor atom, right, and the other atom that accepts this lone pair of electron is your acceptor atom, right? Remember this terminology. So we have donor and acceptor, right, in all compounds that have coordinate bond, right? So the coordinate bond, right, is represented by an arrow, right, like this. It is represented by an arrow which will point from donor towards acceptor, like this, right? And some important points of this coordinate bonding is that this type of bonding was first suggested by a scientist named Perkins, right? This was suggested by a scientist named Perkins in the year 1921, right? And just remember one thing, that one of the atoms in coordinate bond, right, one of the atoms will always possess a lone pair of electrons, right, and the other atom, right, and the other atom is short of electrons, right, short of electrons to complete its octet, right? And this bond is also known as dative bond, right, and is represented by an arrow. Make sure you know from where to where make this arrow. It would be pointed from a donor, like here in this example, from A towards B. This is how a coordinate bond would be represented, right? Now let's take another example. There is one common example where we study coordinate bond formation. It's the formation of ammonium molecule, right? So we will look into the formation of ammonium molecule, right? But before that, let me just tell you one more thing. Like I said here, it's a combination of electrovalent bond and a covalent bond. There is a mechanism, right, that is suggested for for this coordinate bond formation, there is a small mechanism which is suggested, right? It's a simple mechanism. What is said that when this pair of electron, which is a lone pair of electron, right, gets transferred from donor atom to an acceptor atom, what happens is first this one electron, right, will be transferred to the other atom, right. For example, in the example that we have taken of AB, this A possesses a lone pair of electron that has 2 electrons, right? So first this one electron, right, one electron would be transferred to B, right? So when this one electron would be transferred to B, the atom A, right, due to loss of electrons, will acquire a slight positive charge, right? Similarly, the atom B, due to the gain of electron, will acquire a slight negative charge, right? So now this step is similar to your ionic bonding, right, or your electrovalent bonding, right? Now what happens is in the second step, now these two atoms, right, that possesses one electron each, now both these will undergo sharing of electron. The one electron now which is present on A and on B, right, both these atoms will share their one electron, right? Now this is same as covalent bonding, right? So after they share the one electron, this is how it will look like, right? One electron was transferred in the first step, right? Then in the second step, both the atoms that have one electron will share their electrons, will share each of their electrons, right? The second step is same as your covalent bonding, right? So now it's little clear why we say that coordinate bond is a combination of electrovalent bond and your covalent bond, right? So this is your covalent bond and will be represented like this, right, from A towards B. Now how this bond is different from covalent bond? In covalent bond, if you remember, let's move to the next page. In covalent bond, there was sharing of electrons, right? Sharing of electrons, and each of the atoms, right, for example A and B, each of the electrons will contribute, each of the atom will contribute equal number of electrons, right, towards the shared pair of electrons, right? Both the combining atom will share equal number of electrons, right, which is known as covalency. The number of electrons shared by each of the atoms in covalent bond formation is covalency, right? So here sharing of electron takes place between the combining atoms, and each of the combining atoms will share equal number of electrons, right? But when we talk about coordinate bond, in case of coordinate bond, only one of the combining atoms, right, here one of the combining atoms will provide the shared pair of electrons, right? One of the combining atoms will provide the shared pair of electron, will provide the shared pair of electrons, right? So in this case, if this is A and B, right, so here the lone pair of electron will come from one of the combining atoms, right, and later, right, would be shared by both the atoms, right? Now this shared pair of electron which was initially provided by atom A, right, now would be shared by both A and B, right? So after the coordinate bond gets formed, right, it cannot be distinguished from the normal covalent bond, right? That is why we also call it as coordinate covalent bond, right? Coordinate covalent bond, right? So just remember this. Once the coordinate bond gets formed, you would not be able to distinguish it from a normal covalent bond, right? Because the electron pair, which is a lone pair of electron, that is transferred from one of the combining atoms. Once it's transferred to the other atom, which is deficient of electrons, right, towards achieving octet, towards achieving 8 electrons in the outermost shell, once the electron is transferred, that electron pair, which is a lone pair, would be shared by both the combining atoms, right? So that is why it is indistinguishable from a normal covalent bond once it's formed, right? Now let's quickly look into one of the examples, right? So just remember, one of the combining atoms I've written here will provide the shared pair of electrons, and this is an important point. Once coordinate bond is formed, it cannot be distinguished from a normal covalent bond, right? It cannot be distinguished from a normal covalent bond, right? Now let's take example of one of the common example, which is the example of ammonium ion, right? We know that ammonium ion is formed when ammonia combine with a proton, which is a hydrogen ion, right? This hydrogen ion gets formed when hydrogen atom that has only one electron in its outermost shell will lose its only electron, right? So you get ammonium ion like this, right? Now let's look into its formation. This is how it gets formed, right? You have 3 hydrogen atoms, right? And nitrogen atom has one lone pair of electrons, right? So when it reacts with hydrogen ion, which is a proton, as per the concept of coordinate bond formation, it will transfer its lone pair of electron to the other atom, that is hydrogen ion, right? Because hydrogen ion is short of 2 electrons to complete its octet. To complete its doublet, because hydrogen atom has to complete 2 electron in its only shell, right? So once this pair of electron, right, will get transferred to this hydrogen ion, right, then both the atoms, right, that is nitrogen atom and hydrogen ion will acquire 8 electron. Nitrogen will acquire 8 electron and hydrogen will acquire 2 electrons. Nitrogen already had 8 electrons, right, before it transferred, but since it has one lone pair of electron which is not involved in bonding, right, this pair of electron, so it can easily transfer this lone pair of electron to the hydrogen ion. And once this lone pair of electron is transferred to the hydrogen ion, then this lone pair of electron will be shared by nitrogen as well as by hydrogen. So this lone pair of electron will become a common property of nitrogen and hydrogen, right? So this is how it gets formed, right? So here, since nitrogen is providing the lone pair of electron, so nitrogen will be a donor and hydrogen would be an acceptor, right? So coordinate bond would be from donor towards acceptor. This is how coordinate bond will look like, right? Now let's look another example. Let's take the second example of hydronium ion, H3O plus. Right, now this gets formed when water reacts with hydrogen ion, right, like this. It will form hydronium ion. Now if you look into the structure of water, this is how structure of water looks like, right? You have two lone pair of electrons on oxygen atom, on central oxygen atom, right? So when hydrogen ion, which is a proton, will approach, it will transfer one of the lone pair to the hydrogen ion, right? And later, once it's transferred to the hydrogen ion, this lone pair of electron would be shared by both oxygen atom and hydrogen atom, right? So this lone pair of electron now will belong to both oxygen and nitrogen, right? So now it will become a shared pair of electron. So oxygen will look like this. Sorry, water or hydronium ion will look like this. This was transferred to this, right? Oxygen is donor oxygen is donor and hydrogen ion is your acceptor, right? So this is how it is represented, right? Now let's quickly look into orbital concept. Orbital concept. By orbital concepts, we would be looking into overlapping of orbital. How overlapping of orbital takes place, like how overlapping of orbitals occurs, right? Occurs. What happens is, if you just look at this example above, right? Here, this hydrogen ion, if you look at hydrogen ion, when hydrogen will lose its one electron, it will form hydrogen ion, right, like this. So this hydrogen is 1s1, right? So basically it's losing its one electron. Now it has only one orbital. It has one empty orbital, empty s orbital, right? It has one empty s orbital. So when coordinate bond formation takes place, right, in coordinate bond formation, how overlapping takes place in this, in all coordinate bond formation, empty orbital, it's basically in these two examples that we have taken, empty orbital will overlap with the it will overlap with the filled orbital containing lone pair, right, containing lone pair of electrons, right? Now let's look at the formation based on orbital concept in detail, right? Let's look into the formation of ammonia that we have already seen. Let's look into the formation of ammonium ion. And we know that ammonium ion gets formed when ammonia reacts with hydrogen ion, right? And if you remember, we have done this in ammonia. If this is your ammonia, right? In ammonia, this nitrogen atom, this central nitrogen atom is sp3 hybridized, right? sp3 hybridized means it has 4 sp3 hybrid orbitals. We know in sp3 hybridization we have 4 sp3 hybrid orbitals. Let's see how it works. Nitrogen atom, the electronic configuration for nitrogen atom is 1s2, right, 2s2, 2px1, 2py1, 2pz1, right? And electronic configuration for hydrogen is 1s1, right? Now hybridization is based on the concept of mixing of orbitals, right, of nearly equal energies. If you look at this electronic configuration, these orbitals, right, that belong to the same shell, right, 2s orbital and 2p orbitals, it will hybridize. Hybridize means they will mix and merge, right? And they will mix and merge, that is 2s orbitals, and these 3 orbitals will mix and merge and will form a set of 4 hybrid orbitals, because we have 1s 3p, so sp3 hybrid orbitals will form, right? And the number of hybrid orbitals that gets formed is equal to the total number of orbitals that are taking part. Here 1s and 3p, so 4 orbitals, so 4 sp3 hybrid orbitals will get formed, right? So this is how these orbitals will look like. These orbitals will undergo hybridization, and they will form a set of hybrid orbitals. One, 2, 3. Right. This will be 4 orbitals. Right. One is 2s2 orbital. 2s2 that contains 2 electrons. 2s orbital contains 2 electrons. Right. Then 2px orbital, right? Then you have 2py orbital, right? Then you have 2pz orbital, right? This is your 2s2, right? Let me write here. This is your 2px, this is your 2py, and this is your 2pz, right? And these are 1, 2, 3, 4. These are 4 sp3 hybrid orbitals. sp3 hybrid orbitals, right? How will you draw these now? This is how you will draw it. And if you just look at this, you have 3 hydrogen atoms, right? So these are hybrid orbitals, so 3 hydrogen atoms will approach, right? That will have electrons with opposite spins, 3 hydrogen atoms, right? So all these hydrogen atoms have their only electron in 1s orbital, right? So these will overlap with 2px, 2py, 2pz orbitals of nitrogen atom, right? This is how bond formation takes place. These 3 overlapping represents these 3 bonds, right? So how it looks like if you draw the orbital diagram, right? This is the first orbital, 2s2, that has 2 electrons, right? Then you have 2px that has 1 electron. Then you have one more, then you have this, right? So 2px, 2py, 2pz, right? All these four are sp3 hybrid orbitals, right? So let's draw the smaller lobe of these orbitals, all the 4 orbitals, right? Now, like you can see here, these hydrogen atoms, right, which are overlapping with this 2px, 2py, 2pz, we will show it in orbital diagram. This is how overlapping takes place, right? Here 1 electron is from hydrogen, the other is from nitrogen, 2px, 2py, 2pz of nitrogen, right? This is how orbital overlapping occurs, right? So here these three are bond pair of electrons, since bonding took place between nitrogen and hydrogen, and this is your lone pair of electrons, right? And it is this lone pair of electron which would be used in coordinate bond formation, right? In coordinate bond formation, right? So when a hydrogen ion will approach, right? When a hydrogen ion will approach, we know that hydrogen ion gets formed when a hydrogen atom will lose an electron, right? When a hydrogen atom will lose an electron, it will form a hydrogen ion, right? Like this. It will form a hydrogen ion, right? And basically what is happening is 1s electron which is present will lose an electron, right? And it will form, after losing this electron, you have an empty s orbital, right? Now this empty orbital, so basically when hydrogen ion is approaching, it is approaching with its empty s orbital, this empty s orbital, right? It will approach with its empty s orbital, right? Like this. This is the empty s orbital, right, of hydrogen ion, right? So this empty orbital will overlap with the filled orbital of nitrogen atom, right, that contains the lone pair, right? And this is one of the sp3 hybrid orbital, right? So what is happening is the empty orbital here, empty orbital overlapped, the empty orbital overlapped with the filled orbital on nitrogen atom, right? Empty orbital overlapped with filled orbital on nitrogen atom, right? And this filled orbital is sp3 hybrid orbital, right, containing lone pair of electron, right, containing lone pair of electron, which was actually in 2s orbital, if you remember that, right, which was initially present on in 2s orbital before hybridization occurred, right? So this is how covalent bond formation, the coordinate bond formation takes place based on orbital concept, right? Based on orbital concept, what happens is an empty orbital, right, an empty orbital will overlap with the filled orbital, right? This is the orbital concept, right? Now let's quickly look into one more example, right? Let's take the example of a molecule that gets formed between ammonia and boron trifluoride, right? Ammonia, you can write it like this, ammonia, right? It has one lone pair of electron, and boron trifluoride, right? We know that boron has 3 electrons in its outermost shell, right? And 3 of the fluorine atoms will approach it, right, and form 3 covalent bonds. And this is an exception to octet rule, if you remember. Boron has only 6 electrons in its outermost shell, so it can accept 2 electrons to complete 8 electrons in its outermost shell. So what happens is when ammonia and boron will combine, what ammonia will do, the nitrogen atom on ammonia has a lone pair of electron, this, right? This lone pair of electron would be transferred to the boron atom of boron trifluoride, right, resulting into the formation of this adduct molecule. We call it as adduct, right? Since electron got transferred from nitrogen atom to boron atom, this is how it would be represented. Boron, this and this, right? Let me just correct this. It would be like this, right? So here the electron got transferred from nitrogen to atom, so this arrow, right, that represents a coordinate bond will be pointed from nitrogen atom towards the boron atom, right? So I hope this is clear, and if you want, you can quickly look into one more example of sulfur trioxide molecule, right? Sulfur trioxide, SO3, right? How bond formation takes place in SO3 molecule, right? in SO3 molecule, we know that sulfur has 3 oxygen in its outermost shell, right? Sulfur has 3 oxygen, sulfur has 6 electron in its outermost shell, and oxygen also has 6 electron in its outermost shell, right? So sharing of electron will take place, and a bond formation called as coordinate bond formation will also take place, right? Let's see. This is your oxygen atom, right? That has 6 electrons, right? It has 6 electrons like this, 1 2 3 4 5 6, right? Then you have sulfur, 1 2 3 4 5 6, right? You have oxygen, right? This is the formation of sulfur dioxide, right, that I am showing you right now. It has again 6 electrons, right? So here this oxygen atom, right, this oxygen atom has 6 electrons, this sulfur atom has 6 electrons, right? So both these will share 2 electrons, like what happens in normal covalent bond, right? So this sulfur atom will complete its octet, right? And this oxygen atom has also completed its octet, right? Now both oxygen and sulfur has 8 electrons in their valence shell, right? Now what happens in coordinate covalent bond? In coordinate covalent bond, one of the atoms, right, that already has its octet completed, right, will transfer its lone pair of electron to the other atom that is deficient of electron, right? So here one of the lone pair of electron, because this sulfur atom already has 8 electrons, now it can transfer one of this electron to this oxygen atom, right? Now this oxygen atom will complete 8 electrons. It has 6 electrons already. 2 are again transferred from the sulfur atom, right? And this sulfur atom already had 8 electrons. Now this atom, this lone pair of electron, which is transferred from sulfur to oxygen, after it got transferred, now this lone pair of electron will belong to sulfur and oxygen both, right? And how will you show this molecule? This is oxygen, a double bond due to 2 pair of electrons that got shared, a double bond, right? A sulfur, right, like this. Then you have a lone pair of electron that got transferred to the other oxygen atom, right? 1 2 3 4 5 6, right? So this represents, let me just take it little near, it's far away, right? And this transfer of lone pair of electron, which is shown by an arrow like this. So now this has 8 electrons, this has 8 electrons, and this has 8 electrons, right? So one point should be clear from this example, that atoms that already has 8 electrons, that already has 8 valence electrons, will transfer its lone pair, right? Like here, sulfur that already had 8 electrons, this sulfur atom, right, had transferred one of the electron pair to oxygen atom, right? So now all 3 of the atoms have 8 electrons in their valence shell, right? I hope all this is clear to you, right? Thanks.